Hey, this is Mr. Coker with Foundations of Algebra Lesson 9.1, Function Notation. Talking about function notation, what we're referring to is, let's say that we're given a function such as this one, f of x, and this is how it's said, f of x. What it means is f is the name of the function. So this is kind of the value. This is the value of this if it was an expression. What would be the values? So essentially it's the output. So the value of the output when x is in the equation is 3x minus 1. If we change x, if we change the input, which is x, to a different value, what will the output be? That's all we're doing. That probably sounds a little more complicated than it is. But I'll show you how easy it is. First off, when we have a number, this is easy. F of x, meaning the value of the output at x, when x is in the equation, is equals 3x minus 1. We want to find f of 5. So what if instead of an x, if we have a 5? This is, again, this is simple. Take this x, replace it with 5. So I'm going to do 3, instead of 3 times x, I'm going to do 3 times 5 minus 1. Put this whole thing in a calculator and you will get 3 times 5 is 15. 15 minus 1 is 14. F of 5 equals 14. That is easy because it's just a number. You're just putting a number in the calculator. So it's, or into the function, you can put it in a calculator. Put the whole thing in a calculator. It's easy. That's not an exaggeration. I mean, look at it. But just to restate it. When you're given, whatever you're given in parentheses, whatever you're given, when they give you the new input, put that in the equation. One way I've liked to describe it to people sometimes, students in the past who remember how to do equations, is if I'm changing f of x to f of 5, if I'm changing the x on one side, I have to change the x on the other side. If I'm changing x to 5 on this side of the equation, then I'm going to change x to 5 on the other side as well. Even that to me seems a little overcomplicated. Wherever you see an x, put a 5 in its place, solve. Okay, what about if we don't just have a number? Look at this one. This one is called g of x. G is the name of the function. Usually we use f, but that's just because function starts with f. You can use any letter, it doesn't matter. In this case it's g of x, so g is the output at x. Two equals 2x plus 1. Well, this looks like it will be easy if you just saw this part. Of this side, however, it says find g of y minus 1. This looks more complicated. Looks like we're finding g of y minus 1. That's not, we can't just put this in a calculator. Well, the first thing we want to do is put 2, and in place of x, y minus 1. Remember, it's 2 terms. It's a binomial, so I'm going to put it in parentheses. Y times the quantity of y minus 1 plus 1. You have to ugly plus sign. Okay. First off, we use a distributive property. What's 2 times y? Well, of course, it's 2y. We can just call it 2y. 2 times y is 2y. What's 2 times negative 1? Negative 2. So we've distributed, bring down our plus 1 because that wasn't part of the equation. And now we combine like term, or that wasn't part of the distribution. 2y minus 2 plus 1, combine your like terms. Negative 2 plus 1 is negative 1. You can turn this into a negative 1. That was ugly. We're going to turn this into a negative 1. And we have 2y minus 1. And this is g of y minus 1 equals 2y minus 1. So, first part should be easy, and you're going to undoubtedly see these types of problems probably more than any other. And however, it's not enough just to know how to do this. You need to know how to evaluate an expression of some sort. But remember, it's the same process. It just takes a little bit longer. And I've said this many times in this video already, but when you get one that looks like this, it better be easy. This is pretty simple. This does take a little bit of work, but it's the exact same process, and therefore it's still easy. Just takes practice. Anyway, thanks for watching.